every great achievement, like think about a skyscraper or a successful space launch, even a big logistical operation, it always has a really precise plan behind it, doesn't it?
Absolutely. That's a perfect way to frame it. But in the digital world, where the foundation is code and, well, requirements are always shifting, that guiding structure, it's something invisible.
Invisible, yeah, but totally essential.
Exactly. It's rigorous IT project management. And honestly, without that disciplined approach, some of the world's biggest, most ambitious tech ideas, they collapse, sometimes before they even really launch.
It's kind of the hidden backbone.
It really is. We're not just talking about managing a few software updates here. We're talking about the core discipline that makes sure these complex, really unique efforts actually work.
Like building a new AI platform or something huge like migrating a whole company to the cloud.
Precisely those kinds of things.
Yeah.
Things that need to deliver specific strategic results. And, deliver them on time and ideally within budget.
Right. Because the digital world, it doesn't just succeed by chance, does it? It takes structure. It takes that disciplined project management.
It really does. No accidents here.
And so for you listening, maybe you're a graduate student right here in the Dr. Sampak College of Business at Tarleton State University, really focused on, making an impact in organizations. Or maybe you're just aiming to level up your leadership skills in tech, learning how to plan and lead and actually deliver these projects. Well, it starts right here. This is the deep dive for that.
Yeah, our mission today is, well, it's pretty ambitious. We want to unpack the real fundamentals, the concepts, the constraints, those things that kind of box in creativity sometimes, and also the techniques, the practical tools that really drive success in modern IT projects.
So we'll be digging into the core ideas from your source materials, right?
Exactly. Interpreting those insights and, crucially, connecting them directly to the real-world stuff, the things you'll actually use in your future careers.
Okay, and if you find this conversation, this exploration valuable, maybe for navigating your studies or tackling that next big group project or just prepping for your career, please take a quick second to like, follow, and share this deep dive.
Yeah, that really helps others find it. And always, always check the description. We put extra resources there, tailored specifically for your cohort.
Okay, let's start at the beginning then. Let's really unpack this core concept. We throw the word project around all the time, right? Home projects, school projects.
Yeah, we do.
But in IT project management, it sounds like it has a very specific, almost technical definition. And that definition shapes everything else. So what officially makes something a project?
That's a great place to start. The basic definition is actually quite clear. A project is a temporary endeavor undertaken to create a unique product, service, or result.
Okay, temporary. That's the first big keyword.
Absolutely critical. It has a start date, and importantly, it has a definite end date. That's what separates it from operations.
Operations being?
Things like running the payroll system every month or keeping the network stable day to day. Those are ongoing, they're repetitive, they're designed to just sustain the business, keep things running.
Right, so maintaining the current customer database, that's an operation.
Exactly, keeping the lights on.
But if a team gets tasked with, say, designing and rolling out a brand new CRM platform, something totally new, that's a project.
That's it precisely. Because it's unique, it needs new kinds of resources, maybe different skills, and eventually it finishes, gets handed off, and the project team might dissolve or move on.
Okay, temporary and unique. What else?
The other really vital characteristic is something called progressive elaboration.
Progressive elaboration. Sounds fancy. What does it mean in practice?
It just means you don't know every single tiny detail right at the very start, which makes sense for something unique, right?
You can't possibly.
So the characteristics, the features of the final product or service, they start out pretty broadly defined, high level. But then as the project moves forward, as the team learns more, those details get fleshed out. They become much more specific, more refined over time.
Can you give us an IT example of that? How did that look day to day?
Sure. Let's say the CEO says, we need a secure mobile app so our remote folks can handle HR stuff. Okay, that's the start. High level goal. Pretty broad.
Right, mobile app for HR. Got it.
But then, as you move into planning, that vague idea gets progressively elaborated. It turns into specific screen designs, wireframes, detailed security protocols, maybe API specs for connecting to other systems.
It's on the level of like how the forgot password button works.
Exactly. Or the exact encryption standard required for data transfer. That whole journey from that initial vague goal to those super detailed specifications. That is project management in action. And project management itself, the discipline, is defined as applying that specific knowledge, those skills, tools, and techniques to all those project activities. Why? To meet those unique requirements we just talked about. That's KO1 right there.
Okay, so why is this whole discipline so vital, especially in IT, where things can feel a bit intangible sometimes? Code, data. It's not like building a bridge.
Well, to really understand the why, you almost have to look back to the early days when IT projects were, let's just say, notoriously unreliable.
You're talking about the CAS report.
The infamous 1995 Standish Group CAS report, yes. It sent absolute shockwaves through the industry at the time.
What did it find?
It found that the overall success rate for IT projects, and success here meant meeting the basic scope, time, and budget goals they started with, was only, wait for it, 16.2%.
To 16%? That's, wow. Less than 1 in 6 projects actually succeeded.
Dismal, wasn't it? Think about the implications, the wasted money, the missed opportunities. And it gets worse. The same report noted that over 31% of IT projects were just outright canceled before they were even finished.
Over 30% just stopped.
Millions, probably billions, down the drain. It wasn't just that the tech was failing, it was a failure of planning, of coordination, of managing requirements, of communication, a failure of management.
So that history really underlines why we even have courses like this, why formal ITPM exists. It was born out of necessity.
Absolutely. Now, things have improved dramatically since then, thankfully. Success rates have more than doubled, largely thanks to these formalized methods we're discussing. But those CAOS findings, they're still a really powerful reminder. IT projects are complex, they're full of uncertainty. You absolutely need formal, disciplined project management to avoid, well, chaos, to avoid massive waste and sometimes even catastrophic failure for the organization.
Okay, so when we start talking about managing a project, controlling that chaos, the first thing everyone learns about is the triple constraint, right?
That's the classic starting point, the foundational triangle: scope, time, and cost.
Scope being what the project will deliver, time being the schedule, and cost being the budget.
Exactly. And the project manager, the PM, is constantly juggling these three. They're often in tension, pulling against each other. If you try to change one, let's say the client suddenly wants more features, expanding the scope.
Then the PM has to adjust time or cost, or maybe both. You can't just add scope for free without impacting the schedule or the budget.
Precisely. It's a constant balancing act. Let's use an IT example. Say you're building a new e-commerce website. You've got a fixed 6-month deadline. That's your time constraint.
Okay, 6 months. Fixed.
Now, halfway through, the marketing VP comes in and says, hey, we absolutely need this new feature where shoppers can use augmented reality to see furniture in their own living room.
Whoa, okay, that sounds like a huge expansion of scope.
Massive. So the PM's job is to say, okay, we can do that, but we cannot hold the original 6-month deadline unless we significantly increase the cost. Maybe bring in expensive AR specialists, authorize a lot of overtime. Something has to give.
That's the trade-off. You can't have it all without adjusting the triangle.
Right, but, and this is important for modern PM, just balancing those three, it's usually not enough anymore. The thinking has expanded.
Okay, so beyond scope, time, and cost.
We now talk about a broader model, often visualized with 6 key constraints. You still have scope, time, and cost, but you add quality, risk, and resources.
Quality, risk, resources. Okay, how do they fit in?
They directly impact your ability to hit those first 3 goals. For example, if you don't have the necessary resources like skilled developers or enough servers, you're definitely not going to meet your time constraint, or maybe not the scope constraint either.
And quality. I imagine that's often the first thing to get squeezed when time or scope pressures mount.
Sadly, yes. Which is why we need to be really clear on what quality means here, and critically, how it's different from grade. This is a key concept, KO1 again.
Quality versus grade. Okay, break that down for us because they sound similar.
They do, but they're distinct. Quality is all about fulfilling the requirements. It's the degree to which the thing you built, the software, the system, actually meets the needs it was supposed to meet. Does it work reliably? Does it solve the user's problem?
So fitness for use, basically.
Exactly. Grade, on the other hand, is more about a technical category or level based on features or complexity. Think low-grade versus high-grade materials, or basic software versus premium software with tons of features.
Ah, okay. So high grade doesn't automatically mean high quality.
Not at all. You could build, say, a super high-grade security system, multi-factor biometrics, complex encryption, technically very advanced, lots of features. That's high grade.
Sounds impressive.
But if that system is buggy, constantly locks legitimate users out, needs daily patches to keep running, its quality is terrible. because it fails to meet the core requirement of being reliable and usable.
Got it. So high grade, low quality, it's possible.
Very possible. And the PM's job is to manage both. They need to make sure the team aims for the right grade level, the one that actually solves the business problem, not necessarily the fanciest one. And then deliver that appropriate grade with the highest possible quality, making sure it works reliably and actually satisfies the end users. It's a crucial distinction.
Okay, so we have these constraints. We know what a project is. How do we actually manage it all? Project management seems to rely on a structured framework, a kind of roadmap.
It does. The core structure is often described using 5 process groups. These groups basically organize all the different project management activities logically throughout the project's lifecycle.
5 groups, what are they?
They are initiating, planning, executing, monitoring, and controlling, often called M&C,
Okay.
and closing.
Initiating, planning, executing, monitoring, and controlling, closing.
Okay. Now, it's really important to understand these are groups of processes. They're not necessarily rigid sequential phases like in a pure waterfall model. Especially in complex projects, they overlap, they iterate. You might be executing some parts while still planning others, and you're always monitoring.
Okay, so more like logical categories of work than strict steps.
Exactly. But when you look at the number of individual processes defined within each group, one group really stands out.
Which one?
Planning. By far, the planning process group contains the most defined processes. Things like, defining the scope in detail, figuring out all the activities needed, estimating the costs, assigning roles, planning how you'll handle risks. It's huge.
Why is so much emphasis on planning? Why is it disproportionately large?
It goes back to that definition we started with. Projects are unique. If you were just doing a routine operation, the plan would mostly exist already, right? You'd just follow the standard procedure.
Yeah, like running payroll. You follow the checklist.
Right. But since we're creating something new, something unique, we have to invest significant effort up front to figure out the unknowns, coordinate all the pieces, define the resources needed, and basically create the map for this unique journey.
Makes sense. You need a detailed map for uncharted territory.
Precisely. Now, there's a guiding principle here. The amount of planning should be proportional. It should match the project's scope and complexity, and the information you develop needs to actually be useful. Over-planning can be wasteful, sure, but under-planning, that's almost always catastrophic.
Find the right balance.
Find the right balance. And weaving through all of these process groups, kind of holding everything together, is the central role of the project manager, which falls under integration management.
Integration management. That sounds like the PM's core job.
It truly is. You could say it's the glue of the project. Integration management covers all the processes needed to make sure all the different project elements work together as a coordinated whole.
Like what kind of processes?
Key ones include developing the project charter, that's the document that formally authorizes the project to even exist. Then there's developing the overall project management plan, the master blueprint, and directing and managing the actual project work during execution. But maybe the most critical one.
Let me guess. Dealing with changes.
You got it. Performing integrated change control. This is where so many projects go off the rails.
Because change is inevitable, right? Things always come up.
Always. Scope changes, requirements get refined, unexpected issues pop up. But if you don't manage those changes in an integrated way, looking at how a change impacts everything else, the scope, the schedule, the budget, the risks, the quality, the whole project can just fracture.
So the PM acts like a gatekeeper, but also an assessor.
Exactly. They have to take every single proposed change request. Can we add this feature? Can we push the deadline? We need more budget for this. And analyze its total impact. Across all 6 constraints we talked about, and across all the different knowledge areas we're about to discuss. They are the ultimate coordinator, ensuring, for example, that a seemingly simple schedule change doesn't accidentally introduce a massive quality risk or create a communication breakdown somewhere else. That integration piece is vital.
Okay, so if the process groups tell us how and when the work gets done through the project lifecycle, what about the what? What specific areas does a PM need to know about?
That's where the 10 knowledge areas, or KAs, come in. These represent the specific disciplines, the core subjects that a project manager needs to master. This is KO3 territory, demonstrating knowledge of these terms and techniques.
10 areas. Can you list them for us?
Sure, they are. Integration, scope, time, cost, quality, human resource communications, risk, procurement, and stakeholder management.
Okay, that's a lot. Integration we just talked about. Scope, time, cost, quality. Those link back to the constraints.
Yeah.
Then HR, communications, risk, procurement, stakeholders. covers pretty much everything.
It's comprehensive, and it forms the common knowledge base that certified PMs like PMPs share globally. Now, while you need competence across all 10 in IT projects, some tend to be particularly critical for success.
Which ones would you highlight for IT?
While integration is always key for the PM role itself, but beyond that, I'd say scope management is huge because requirements drift is so common in IT. Communications, definitely. And risk management.
Let's spend some real time on risk management. You mentioned uncertainty is inherent in IT. This feels crucial.
It absolutely is. It ties directly into what newer frameworks call the uncertainty performance domain. Projects, by their unique nature, involve uncertainty. Risk management is the formal process for dealing with that, identifying potential uncertain events, analyzing them, and planning how to respond if they happen.
And risks aren't always bad, right?
That's a critical point. We tend to focus on the negative risks, the threats. But a risk is just an uncertain event. It could also be positive and opportunity.
Like finding a faster way to do something, or a new technology emerging.
Exactly. And good risk management plans for both. You want to enhance the opportunities, increase their probability or positive impact. And for the threats, you want to reduce their probability or negative impact.
So the process involves identifying them first, then analyzing.
Right. You start by identifying risks, brainstorming everything that could happen, good or bad. Then you typically do qualitative risk analysis, figuring out which risks are most important based on likelihood and impact. Maybe even quantitative analysis for the really big ones, putting numbers on them. And then, the crucial step, plan risk responses. What are we actually going to do about these risks?
Okay, let's talk responses. What are the standard strategies, especially for the negative ones, the threats? This sounds like really practical stuff our listeners need to know.
Absolutely. There are 4 main strategies for dealing with threats.
Okay, number 1.
Avoidance. This is the most powerful if you can do it. You basically change the project plan to eliminate the threat entirely. Maybe you change the scope, use a different technology, choose a different vendor. You sidestep the risk altogether.
So if it's integrating with some shaky old legacy system is risky?
You might decide to avoid that risk by building a new, standalone feature instead, even if it takes more work initially. You've avoided the integration headache.
Makes sense. Okay, number 2.
Transfer. Here, you shift the risk, or at least its impact, to a third party. You don't eliminate it, but you make someone else responsible for the consequences, usually financially.
Like buying insurance.
And insurance is the classic example. Or signing a fixed-price contract with a supplier. If their costs overrun, they bear that risk, not you. You've transferred it.
Got it. Third strategy.
Mitigation. This is probably the most common one. You take actions to reduce the probability of the risk happening, or to reduce its impact if it does happen.
Can you give an example?
Sure. To mitigate the impact of a server failure, you might build a high availability cluster. If one server goes down, another takes over instantly. The impact is lessened. Or, to mitigate the probability of security bugs, you conduct really rigorous code reviews before release.
Okay, reduce likelihood or reduce impact. And the last one.
Acceptance. This means you decide to, well, do nothing proactively. You acknowledge the risk exists, but maybe it's too expensive to mitigate, or the chance of it happening is super low.
So you just hope for the best?
Not quite hoping. You might do passive acceptance, which is just documenting it. Or you might do active acceptance, where you set aside a contingency reserve, extra time or money specifically to deal with that risk if it occurs. You have a fallback plan, but you're not acting upfront.
Avoid, transfer, mitigate. Accept.
Okay.
And this is all about planning for risks. What happens when a risk actually occurs?
That's a key distinction. Once a negative risk happens, say, that key vendor you were worried about actually does go bankrupt, it's no longer a risk. It's now an issue.
An issue, meaning?
Meaning it's a current problem that needs immediate attention. You stop planning for it and start actively managing it, problem solving, implementing your contingency plan, or figuring out a workaround. It shifts from proactive planning to reactive management. Hashtag 2.3 tools and techniques in practice, KO3.
Right, so we have the process groups, the knowledge areas. The third leg of this stool seems to be the actual tools and techniques. The practical methods PMs use day-to-day to get control. This is also part of KO3, right? Knowing the techniques.
Definitely. These are the how-tos, and there are tons of them. But let's focus on a few core ones, especially around estimating and control, because that's where a lot of the hard-won experience comes in.
Okay, let's start with cost estimating. How do you estimate costs when things are still, progressively elaborating?
Great question. The key idea here is accuracy progression. Your estimates have to get better, more accurate as the project moves forward and you know more details.
So early on, the estimate is pretty rough.
Very rough. At the very beginning, maybe during initiation, when you just have a high-level idea, you're likely doing a rough order of magnitude estimate or ROM.
ROM estimate. How rough are we talking?
Think wide bands. Maybe DUT is 25% on the low end to plus 75% on the high end compared to the final actual cost. It's really just a ballpark to see if the project is even feasible.
Wow, that's a huge range. So negative 25% to plus 75%.
Yep. But as you move through planning, as the scope gets defined, the requirements are clearer. You need to narrow that down significantly. By the time you're ready to get budget approval or start execution, you should be aiming for a definitive estimate.
Definitive estimate. How accurate is that?
Much tighter. Maybe negative 5% to plus 10%, close enough to manage the budget effectively. And we use specific techniques to get from that wide ROM to the tight definitive estimate.
What are some of those techniques?
Well, there are several common ones.
Right.
Analogous estimating. This is quick, often used early on. You look at a similar project you've done in the past, one that's analogous, and you use its actual cost or duration as a starting point for your current project's estimate. You might scale it up or down a bit.
Fast, but maybe not super accurate if the projects aren't really similar.
Exactly. Its accuracy depends heavily on how good the analogy is.
Oh, then there's
Parametric estimating.
parametric.
This uses a statistical relationship. You use historical data to find a parameter, a unit cost. For example, if past data shows it costs, say, $50 to implement each user license for a certain type of software.
Okay, $50 per license.
And your new project needs 1,000 licenses. Boom. You can parametrically estimate $50,000. It's usually much more accurate than analogous, especially if the parameter is reliable.
Right, if the data holds up, what else?
Bottom-up estimating. This is the most accurate, but also takes the most effort.
How does it work?
You break the project down into the smallest pieces of work, the work packages at the bottom of your work breakdown structure. You estimate the cost and effort for every single one of those tiny pieces, labor, materials, everything. Then you add them all up, aggregate them, rolling them up to get the total project estimate.
Detailed, time-consuming, but precise.
Very. And then there's three-point estimating, which is really valuable because it acknowledges the uncertainty we keep talking about.
3-point. Like best case, worst case.
Exactly. Instead of just one single number, you develop 3 estimates for each activity. An optimistic estimate, O, best case scenario, a most likely estimate, M, realistic case, and a pessimistic estimate, P, worst case scenario, if things go wrong.
And you combine those somehow.
Yes. You typically calculate a weighted average. The most common formula used in Peer program evaluation and review technique, is O plus 4M plus P6.
No.
It gives more weight to the most likely estimate, but factors in the possibility of the optimistic or pessimistic outcomes. It gives you a much more realistic range and expected value than just a single point guess.
Okay, that makes a lot of sense for dealing with IT uncertainty. Now let's shift to schedule management. What happens when the project starts slipping? Deadlines are looming. What tools does the PM have?
When the schedule is in trouble, the PM has 2 main compression techniques they might try: crashing and fast tracking.
Crashing and fast tracking. Okay, what's crashing? Sounds aggressive.
It kind of is. Crashing means you analyze the schedule to figure out how to shorten the project duration for the least possible additional cost. Usually this means adding more resources to critical path activities.
Like throwing more developers at a task. Or authorizing overtime.
Exactly. You're spending more money, increasing the cost to buy back time. The trade-off is clear. Schedule potentially improves, but costs definitely go up. And you also risk burning out your team.
Okay, so crashing costs more money. What about fast tracking?
Fast tracking is different. Here, you take activities that were originally planned to happen one after the other in sequence, and you rearrange them so they happen in parallel, or at least overlap significantly.
Like starting the testing phase before the coding is 100% finished.
That's a classic example. You're hoping to save overall time by doing things concurrently.
What's the trade-off there? Does it cost more?
It might not increase costs directly, at least not initially, but the trade-off is a significant increase in risk.
How so?
Well, if you start testing based on incomplete code and that code turns out to have fundamental flaws, all that testing work you did in parallel might be useless. You might end up having to do massive rework later. Remember that cost of change curve we'll talk about? Fast tracking can lead right into that expensive rework if you're not careful.
Right. Doing things in parallel increases the chance of errors or needing to redo work. Big risk.
Huge risk. So crashing adds cost, fast tracking adds risk. The PM needs to weigh those carefully.
This all leads to needing good control mechanisms. How do you track if you're actually on schedule and on budget, especially when using these techniques?
That brings us to a really powerful tool, maybe the key tool for integrated performance measurement, earned value management, or EVM.
EVM, I've heard of that. It sounds complex, but important.
It can seem complex at first, but the core concepts are straightforward and incredibly valuable. If our graduate students master just one monitoring tool, EVM should probably be it. It gives you an objective, data-driven way to measure project performance by integrating scope, schedule, and cost.
Okay, how does it work? What are the basics?
It revolves around 3 core metrics, usually measured cumulatively at specific status states.
Metric number 1.
Planned value, PV. This is simply the budgeted cost of the work that was scheduled to be completed by that status state. It's your baseline plan.
Okay, what you plan to spend on the work you plan to do.
Exactly. Metric number 2 is earned value, EV. This is the budgeted cost of the work that was actually completed by that status date. This is the crucial one. It measures your actual progress in dollar terms based on the plan.
Okay. What the work you actually did is worth, according to the budget.
Perfect. And the third metric is actual cost, AC. This is just what it sounds like.
Okay.
The actual amount of money you spent to accomplish the work that you completed by that status date. Your real spending.
PV, planned, EV, earned, AC,
Actual,
active.
got it. So how do these tell you if you're doing okay?
The real power comes when you compare these values, usually by calculating performance indices, 2 key ones, CPI and SPI.
CPI and SPI, what do they stand for?
CPI is the cost performance index. You calculate it by dividing earned value, EV, by actual cost, AC.
EV divided by AC. What does that tell you?
It tells you your cost efficiency. If your CPI is, say, 0.90, it means for every dollar you actually spent, AC, you only earned 90 cents worth of planned work. EV, you're over budget. A CPI less than 1.0 is bad news for costs.
Okay, less than 1 is over budget. What about SPI?
SPI is the scheduled performance index. You calculate it by dividing earned value, EV, by planned value, PV.
EV, PV.
EV divided by PV. And that tells you
Your schedule efficiency. If your SPI is, say, 0.85, it means you've only accomplished 85% of the work that you had planned to accomplish by this point in time. You're behind schedule. And SPI less than 1.0 means you're falling behind.
So for both CPI and SPI, less than 1.0 is bad, 1.0 is exactly on target, and greater than 1.0 means you're doing better than planned. Ahead of schedule or under budget.
Precisely. And this gives the PM objective data. It's not about feelings or excuses. It's about the numbers. Our CPI is 0.9. We need to address cost overruns. Our SPI is 0.85. We need to find ways to get back on schedule.
And can you use this to predict the future too? Like estimate the final cost?
Absolutely. Based on these current performance indices, you can calculate forecasts like the estimate at completion, EAC, what the project is now likely to cost in total given the current performance. It's incredibly useful for realistic forecasting and for taking timely corrective actions.
Wow. Okay, EVM seems like a really essential tool for keeping things under control. It moves the conversation to data.
Exactly. It's a cornerstone of effective monitoring and controlling. Okay, we've talked a lot about processes, tools, constraints, the hard side of project management. But for anyone aiming for leadership roles, especially you folks in the graduate program thinking SO1, SO2, SO3 here, focusing only on the technical stuff, that's just not enough.
Right, there's a huge human element involved.
Huge. Industry research, like from PMI with their talent triangle, consistently shows that the highest demand is for PMs who have this specific mix. Yes, you need the technical project management skills we've been discussing, but you also need strong leadership skills and, crucially, strategic and business management acumen. It's that blend that really makes a difference.
That blend takes you from just coordinating tasks to actually leading strategically.
Exactly. And often it's the so-called soft skills that truly set successful PMs apart. Let's talk about one that's just massive in terms of time commitment. Communication.
I've heard a crazy statistic about this.
It is pretty staggering. Studies suggest project managers spend something like 90% of their time communicating.
90%. That's almost the entire job.
It feels like it sometimes. And we're not just talking about writing status reports or sending emails, though that's part of it. It's about managing stakeholder expectations. It's resolving conflicts between team members. It's motivating people when things get tough. It's clearly reporting progress and risks up the chain. If communication breaks down, the project is almost certainly doomed.
If the PM can't clearly articulate the vision, the why,
Then the team doesn't have a clear target to aim for. They might just be executing tasks without understanding the bigger picture, which leads to mistakes and inefficiency.
And this communication, it's not just one way, right? It's happening in all directions.
All directions. It's written, it's oral, it's formal, think project review meetings, official reports, and it's informal, those quick chats in the hallway, instant messages, ad hoc problem-solving sessions.
And it's also horizontal and vertical.
Yes. Horizontal communication is with your peers, other PMs, stakeholders at roughly the same level in the organization. Vertical communication is reporting upwards to your project sponsor or senior management, and also downwards to your project team members and maybe functional managers.
And managing that vertical flow must be tricky. You probably talk very differently to your sponsor than to your tech lead.
You absolutely have to. The level of detail, the focus, it's completely different. With your sponsor, you're likely talking strategic alignment, key milestones, financial performance, maybe those CPI and SPI numbers from EVM. With your technical team, you're deep in the weeds of deployment schedules, specific coding challenges, or resource constraints. A really good PM is essentially multilingual within the organization. They can switch between those different communication styles effectively.
Okay, communication is huge. What's another critical soft skill?
Negotiation. Project managers are constantly negotiating. It's almost like being an internal diplomat sometimes.
Negotiating what specifically?
Almost everything. You negotiate for the best resources with functional managers who might have competing priorities. You negotiate scope objectives and priorities with stakeholders who all want different things. You negotiate contract terms with external vendors. You negotiate schedule changes and assignments with your own team members. You negotiate change requests. It's constant.
So understanding how to negotiate effectively is key. Are there different styles?
Definitely. And knowing when to use which style is important. We often talk about three main approaches.
Okay, what's the first one?
Compromise, sometimes called reconcile. This is often the go-to when time is tight. Both sides give up something to find a middle ground. Nobody gets everything they wanted, but you reach an agreement quickly.
Quick fix, but maybe not the best outcome.
Often, yeah. It can lead to a lose-lose or a minimally acceptable solution rather than the optimal one. Then there's collaboration or problem solving.
Collaboration sounds better.
It usually is. This is the ideal approach, aiming for a true win-win. You work together with the other party to understand the underlying needs and find a solution where both sides get what they really need without having to sacrifice core objectives. It takes more time, more trust, more open communication, but it usually leads to the best, most sustainable results.
Win-win. Okay. And the third style?
Competition, sometimes called forcing. This is a win-lose approach. You push hard for your position, using your authority or leverage to get what you need, even if the other party isn't happy.
When would a PM use that? Sounds kind of harsh.
It can be, and it can damage relationships long-term. But you might use it if you have significant positional power, or if time is absolutely critical and the issue is non-negotiable, like meeting a mandatory legal compliance deadline. Or maybe if the stakes for the project are incredibly high and compromise isn't an option. The skilled PM knows how and when to shift between these styles, collaborating when possible, compromising when necessary, and competing strategically to protect the project's core goals. Hashtag 3.2 leading people and managing things.
This brings up that classic distinction, doesn't it, between leadership and management. People often say, you lead people, you manage things. Project managers have to do both, right?
They absolutely do, and the source materials really emphasize this. Effective leadership is often highlighted as the single most important factor contributing to project success. More than tools, more than process sometimes.
So what's the difference in focus? Manager versus leader.
Generally speaking, the manager focuses more on the doing things right part. The day-to-day execution, making sure processes are followed, tasks are completed efficiently, resources are allocated correctly. It's about maintaining order and control.
Okay, keeping the trains running on time.
Exactly. The leader, on the other hand, focuses more on doing the right things. They're looking at the bigger picture, setting the vision, inspiring and motivating the team, ensuring the project stays aligned with the organization's overall strategy, navigating obstacles, and championing the project.
So the leader provides the why and the direction.
Precisely. Effective leaders, the ones who really drive success, tend to be visionary. They can articulate that compelling picture of the future. They're decisive, technically competent enough to understand the challenges the team faces, and crucially, they lead by example. Their behavior sets the tone.
You mentioned setting the vision. How important is having a clear project vision statement, especially for IT projects where the outcome might seem a bit abstract?
Oh, it's incredibly important. A good vision statement isn't just fluff. It describes a realistic but also attractive and inspiring view of what the project will achieve. What will the future look like when this is done?
It gives people purpose.
Exactly. It gives the team and the stakeholders a shared goal, a unifying why. If people understand why they're putting in the extra hours or why these security protocols are so strict, they're much more likely to be motivated and make the right choices along the way, which ties directly into understanding what actually motivates your team members.
Right. And for our students who are going to be leading teams, SO3, this isn't just about giving orders. It's about understanding motivation, especially the intrinsic stuff, right? The things money can't necessarily buy.
Absolutely. Intrinsic motivators come from the work itself. Things like a sense of achievement, I built that, or the enjoyment of a challenge tackling a tough problem, the need for self-direction or autonomy, having control over how you do your work, or the feeling of making a meaningful personal contribution.
So a good PM needs to figure out what drives each person on their team.
A skilled PM does, yes, they observe. Is this engineer really motivated by tackling complex new problems? Then give them a challenging assignment, a stretch goal. Don't just give them routine bug fixes. Is this analyst someone who thrives when they have autonomy? Then avoid micromanaging them, give them the goal, and let them figure out the best way to get there. Knowing what intrinsically motivates each person allows you to tailor your approach and, frankly, elicit their best work.
That sounds like real leadership. And it contributes to building a high-performing team, I imagine.
Definitely. High-performing teams don't just appear out of nowhere. They need to be cultivated.
What are the signs of a really effective team?
You see things like high commitment to the project goals, a lot of creativity and innovation in solving problems, good communication, mutual trust, and maybe most importantly, the ability to handle conflict constructively. They don't avoid conflict, but they work through it productively.
And the flip side. What usually trips teams up? What are the common barriers?
Oh, there are classics. Different team members having completely divergent views on what the priorities are. A lack of clarity about the project's actual objectives. People aren't sure what done looks like. Persistent communication problems, maybe information silos. And often an unclear or even conflicting leadership structure who's really in charge. These things can absolutely sink a team.
And the leadership style needs to adapt too, right? You wouldn't lead a brand new team the same way you'd lead a team of seasoned experts.
Not at all. Your style has to fit the situation and the team's experience level. A new, inexperienced team might need a more directive, guiding approach initially, whereas a highly experienced, mature team might thrive under a more delegating or coaching style where you empower them more. It's about flexibility.
Okay, let's shift gears a bit and talk about the modern landscape of IT projects. It feels like the way we do projects has evolved a lot. It's not just one-size-fits-all anymore, is it? This seems critical for KO2, evaluating situations and applying the right concepts.
Not at all one size fits all. That's a key understanding today. The Project Management Institute, PMI, and the industry in general now recognize a whole spectrum of development approaches. The choice of which methodology to use is actually a major strategic decision for the PM and the organization.
A spectrum. What's on this spectrum?
Broadly, we talk about three main categories, largely based on how stable the requirements are and the overall complexity. Predictive, which is your traditional waterfall approach, adaptive, which includes agile methods, and hybrid, which mixes elements of both.
Okay, predictive waterfall. That's the one we often think of first, right? The linear, step-by-step process.
Exactly. You do all the requirements gathering up front, get sign-off. Then you design everything. Then you build or code everything. Then you test everything. Then you deploy. Very sequential, like a waterfall flowing down steps.
When does that make sense?
It's still the preferred, sometimes even mandatory approach when the project objectives are really well understood and stable from the start, when the design isn't expected to change much, and especially when there are very strict safety or regulatory requirements involved.
Like building, I don't know, software for a medical device.
Yeah.
Or maybe large physical construction.
Perfect examples. Situations where making changes late in the game is incredibly expensive, or even dangerous. You need that upfront certainty and rigorous documentation.
But so many IT projects, especially software ones, aren't like that. The ground is constantly shifting. Requirements change.
Precisely. And that's where adaptive approaches, most notably agile, really took hold and transformed software development.
Agile. We hear that word everywhere. What's the core idea?
Adaptability is the key word. Agile methods prioritize responding to change over rigidly following a plan. They focus on delivering value quickly and incrementally. usually in short cycles called iterations or sprints, often just 1 to 4 weeks long.
So you build a little bit, show it, get feedback, then build the next little bit.
That's the essence. You deliver working software or a working product increment frequently. This allows the stakeholders, the customers, to see tangible progress, test it out, and provide immediate feedback. That feedback then shapes the requirements for the next iteration.
So it embraces change rather than fighting it.
Exactly. It's ideal for projects where the requirements are expected to evolve, where there's a lot of uncertainty, or where you want close collaboration with the customer throughout. Think software development, web development, R&D projects.
Okay, so we have predictive waterfall for stable stuff, adaptive agile for changing stuff. What about this hybrid category?
Hybrid is really about pragmatism. It acknowledges that for many large, complex projects, especially in big organizations, neither pure waterfall nor pure agile might be the perfect fit. So hybrid blends them.
How does that work in practice, mixing oil and water?
It sounds tricky, but it can be very effective. You might use a more predictive approach for the high-level planning, setting the overall budget, defining major milestones, establishing the core architecture, very structured upfront for the big picture.
Okay, so the framework is waterfall-ish.
Right, but then for the actual execution, especially for the parts of the project where there's more uncertainty, like developing specific user features or designing the user interface, you use adaptive agile iterations, short sprints, feedback loops, flexibility.
Can you give an example of where hybrid works well?
Think about a big multi-channel marketing campaign. The overall launch date and the total budget might be fixed well in advance. That's your predictive part. But how you develop the specific ad creatives, which social media tactics you use, how you run A/B tests, that might be handled in flexible 2-week agile sprints, adapting based on what's working.
Or maybe building a smart building. The physical construction is waterfall, but the software integrating all the sensors and controls could be agile.
Another excellent example, recognizing when to use predictive, when to use adaptive, and when a hybrid approach, KO2, makes the most sense, is a really critical skill for modern IT project managers. It's about choosing the right tool for the specific job. #tag toward 4.2, focusing on outcomes and value, KO2.
And this move towards choosing the right methodology, being flexible. It feels like it's part of a bigger shift in project management philosophy, isn't it? Less focus just on process for process's sake.
Absolutely. The latest evolution in the industry standards, like the PMBOK Guide 7th edition from PMI, reflects this. There's a much stronger emphasis now on principles, 12 guiding principles, and on performance domains, 8 key areas of focus, rather than just rigidly following prescriptive processes.
So less focus on how you do it and more on what you achieve.
Exactly. The ultimate goal, the driving force, is delivering outcomes and value.
Value, that word keeps coming up. What does it really mean in a project context?
Value is the ultimate indicator of success. It's the net quantifiable and unquantifiable worth or benefit that the project delivers. If a project hits its scope, time, and cost targets perfectly, but ultimately fails to deliver any real value to the organization or its customers, it's still a failure.
So value can be more than just dollars and cents.
Oh, definitely. It can be quantitative, sure, things like increased revenue, higher market share, reduced operating costs, a specific return on investment, ROI, but it can also be qualitative things like improved customer satisfaction, enhanced brand reputation, greater employee morale, compliance with regulations, or contributing to the public good.
And the PM's job is to keep the project focused on delivering that intended value.
Constantly. It's about continually evaluating. Is what we're doing still aligned with the original business objectives? Is this feature really going to add value, or is it just scope creep?
That focus on value, KO2, helps the team make better decisions throughout the project.
This focus on value seems to tie back directly to something we touched on earlier, proactive quality management, ensuring you build value in, not just check for it at the end.
It absolutely does, because poor quality destroys value faster than almost anything else. This is where understanding the cost of change becomes so critical.
You mentioned a visualization for this, the Bohm curve. Yes, the Bohm curve, it's often shown as figure 222 in project management texts. It's a powerful visual that graphically shows how the cost to fix an error or a quality problem increases dramatically, exponentially, even the later you find it in the project lifecycle.
Exponentially. Can you break that down? Give us the scale of it.
Sure. Let's say you make a fundamental error in understanding a requirement right at the beginning, during the design phase. If you catch it then, the cost to fix it might be minimal. Let's call it 1x. Just redraw the design, update the spec.
Okay, 1x cost. if caught early in design.
Right. Now, if that same error isn't caught until the testing phase, after the code has been written based on the faulty design, now the cost to fix it might jump significantly, maybe 10x, maybe 50x the original cost, because now you have to rewrite code, redo tests, update documentation, much more effort involved.
10x to 50x if caught during testing. Ouch.
It gets worse. What if that error, that bug, escapes testing and makes it out into the production environment? It gets discovered by the end user. We call this an external failure.
The worst case scenario.
Absolutely. The cost to fix it now, it could easily be 100x, even 150x or more compared to fixing it back in the design phase, because now you've got the cost of emergency patches, maybe data corruption issues, potential system downtime, damage to your company's reputation, customer support costs, maybe even lost customers. The cost explodes.
Ooh. 1x in design, maybe 50x in testing, 150x or more in production. That's a staggering difference.
It really is. And it provides the economic justification for why PMs must focus so intensely on proactive quality, engaging stakeholders early and often, doing rigorous reviews, building quality checks into the development process itself. It's not just about making things nice, it's about avoiding potentially catastrophic costs down the line. Build quality in, don't just try to inspect it in later. Hashtag 4.3 professionalization and career impact, SO1, SO2, SO3. So pulling this all together, this whole deep dive really underscores why formal training and professionalization in project management are so important. Mastering these concepts, these frameworks, these skills, it opens up significant career opportunities.
Yeah, we hear all the time that project management skills are in high demand, often listed as top tech skills. And the salaries can be pretty strong too, right? SO1?
Definitely.
Yeah.
Organizations in every sector need people who can successfully manage complex initiatives and deliver results. And the recognized standard for demonstrating that capability often comes through professional bodies and certifications.
Like the Project Management Institute, PMI, that you mentioned.
Exactly. PMI is the globally recognized leader in setting standards and certifying project management professionals. Their main certifications, like the Project Management Professional, PMP, for experienced PMs, and the Certified Associate in Project Management, CAPM, for those starting out, provide a common, rigorous benchmark of knowledge that employers worldwide trust.
And these certifications have become pretty widespread.
Massively so. The growth in PMP certifications globally has been huge. The sources mentioned hitting over 639,000 certified individuals way back in 2014, and it's only grown since. It just shows the universal recognition of the need for a structured, competent approach to managing projects. For our listeners in the graduate program, pursuing these kinds of certifications is a clear signal to employers that you've mastered this body of knowledge, the 10 KAs, the 5 process groups, the tools and techniques.
And this professional foundation, this body of knowledge, it ties directly back to what students are doing in the course curriculum here, doesn't it? SO2, SO3.
Absolutely. The course description itself emphasizes learning the concepts and techniques, but crucially, it requires students to apply that knowledge.
How so?
Through the group project. Students have to work together, either taking on the role of the project manager or being an active, contributing team member.
So it's hands-on.
Very hands-on. This structure is designed specifically to foster those key skills outcomes. Students need to use research skills to investigate current PM topics, SO1. They have to practice the management skills needed to navigate the different related phases of a real project lifecycle, SO2. And critically, they develop those teamwork and leadership skills, SO3, by actually collaborating to complete a complex semester-long project.
So the real learning isn't just memorizing the definition of, say, a work breakdown structure.
Right. It's about actually using that WBS concept to guide your team through planning. It's about leading your team through execution, dealing with the inevitable issues, monitoring progress using tools like EVM perhaps, and ultimately delivering something of value by the end of the semester. It's about applying the knowledge and developing the leadership capabilities. That's the real takeaway. Hashtag outro.
Well, this has been a fantastic deep dive. We've really laid the groundwork for IT project management, starting with what a project even is: temporary, unique, progressively elaborated, and distinguishing it from ongoing operations.
Yeah, and we mapped out the essential frameworks, the 5 process groups guiding the life cycle, the 10 knowledge areas covering the disciplines PMs need to master.
We explored the constraints, moving beyond just scope, time, and cost to include quality, risk, and resources. And we got into some practical tools like estimating techniques and earned value management for control.
And critically, we didn't forget the human element. That huge role of communication, 90% of the PM's time, negotiation skills. and the difference between managing tasks and truly leading people by understanding motivation and team dynamics.
We also situated all of this within the modern landscape, looking at the spectrum of methodologies, predictive, adaptive, hybrid, and the crucial shift towards focusing on delivering outcomes and real value.
And we highlighted the importance of proactive quality, remembering that Bohm curve and the exponential cost of fixing errors late in the game.
So for all of you listening, especially our graduate students here at Tarleton or tuning in from elsewhere, if you're ready to keep mastering this absolutely critical skill set, please do follow the show.
And definitely check out the description. We've put links there to expand on today's discussion, more on PMI, maybe some resources on EVM, or that Bohm curve we talked about.
Okay, and as we wrap up, we always like to leave you with a final thought, a reflective question based on what we've discussed.
So here it is. If every single critical IT project suddenly failed tomorrow, imagine server migrations halt, security patches get canceled, new software development just stops dead. What single foundational part of your daily world, your work, your banking, your communication, maybe even just your ability to order coffee online, what would come crashing down first?
Think about that reliance, that quiet, ubiquitous dependency. That's the true measure of project management's profound and often totally invisible success.
Absolutely, because behind every app launch you see, every secure online transaction you make, every major tech innovation that changes things, there's disciplined IT project management making it all possible.
Until next time, keep exploring the fascinating world where ideas become projects and where those projects truly shape our future.